In this video, I am going to show you how to use Detectron2 to train a custom object detector. So this is the repository I am going to use in this video. This is Detectron2 official repository. In case you are not familiar with Detectron2, it's the state-of-the-art in object detection and also in other computer vision tasks as semantic segmentation or panoptic segmentation and so on. So this is an algorithm I use very often in my projects, for example, in object detection problems, and I have seen it has a very high performance. It has a very good performance. It's a very robust detector. It may not be the most fast detector. It may not be you're not going to achieve a real-time detection using Detectron2, but it offers a very good performance. And if you don't need a real-time detection, if you're okay having only a few frames per second, then most likely you are going to be fine with Detectron2. So let's start with it, and the first thing I am going to do is go into this section, which is the installation, and let's see what are the installation instructions for using Detectron2. One of the things I want you to take from this video is how easy, how simple it is to train an object detector algorithm using Detectron2. That's one of the main things I want you to take from this video. And for example, if we go to the installation of Detectron2, you can see that this is only a few lines. It's going to be the same process as installing a Python library, like any other Python library, like NumPy or Pandas or OpenCV and so on. You can see it's basically a pip install. We have to run a pip install, and that's going to be enough. Please notice the dependencies for installing Detectron2, which are sorry, I don't know what I click. PyTorch in its version 1.8, and also Torch Vision. And please make sure you have these two libraries installed before installing Detectron, otherwise it may not work. So let's start with it, and I am going to show you how I install Detectron2 and I install all the dependencies in my local file system. So this is a project I have created in order to show you, in order to make this video, and I have already created a virtual environment. So what I am going to do now is to install Detectron and all the necessary libraries. And if I show you the requirements file, you are going to see I am going to install Torch Vision, OpenCV, and Matplotlib, and also obviously Detectron2. And what I'm going to do before installing all these dependencies is to comment the line that it's about installing Detectron2. What I'm going to do is to install all these dependencies first, and then I am going to install Detectron2. So pip install -r requirements. This is going to take a couple of minutes. Okay, so I have installed all these dependencies, so what I am going to do now is to uncomment this line and to run the same command, and I am going to install only this dependency because everything else is already installed. So everything seems to be okay. Okay, so everything seems to be okay with the installation. So what I'm going to do next is to continue with the tutorial. So we have already installed all the necessary dependencies, all the necessary libraries, and you notice how fast, how easy that was. So now let's continue to how to use Detectron2 to train a custom object detection algorithm. And for this, I am going to show you this Jupyter notebook, which is the Detectron2 official tutorial on how to train a custom object detector. But what I am going to do is to walk you through this notebook and then to show you how I took things from this notebook in order to create my own script to train Detectron2. Because I have seen that many people use notebooks because it makes everything nicer and cleaner and good looking. But what I have noticed in some cases, for example in this case, is that everything, I mean, it's cleaner and it's nicer, but it's also a little confusing, or at least that's my impression when I go through this notebook. For example, there's at first we have the installation of Detectron2, Then we have some imports. Then it's running a pre-trained model, so we see a picture. Then it's something like a config. Then it's the train on a custom dataset, something about preparing a dataset. Maybe it's me, but if I go through this notebook, or every time I went through this notebook, I've always had the same impression that it's a little confusing. There are many different things going on, and it gets a little confusing. For example, here it's like preparing the dataset and registering the datasets in Detectron2, and then it's like plotting some images and visualizing the bounding boxes. It's for me it's a little confusing. So what I am going to show you is how I took things from this notebook in order to create my own script to train a custom object detector. So if we go through this notebook, you are going to see that basically all we need is starting here, training a custom dataset, and it all starts with preparing a dataset, right? It downloads a dataset, and then it runs this cell, which is something like registering this dataset in Detectron2. This registering the dataset in Detectron2, it's something that it makes sense in Detectron. I mean, it's something Detectron needs in order to be able to train on this dataset. So the first step will be to download a dataset, and then we have to register this dataset in Detectron2. And then once our dataset is registered, the next step will be to run this cell, which is basically the training. This is a config file, something like a configuration to configure the Detectron2, how everything is going to be done, how the training is going to be done, all the different hyperparameters, for example, the learning rate, how many iterations, which is related to the number of epochs. If you are familiar with training a deep learning algorithm, I'm sure you are familiar with the number of epochs. Well, the number of iterations is like a similar concept. And so on. This is where we specify all the different hyperparameters, and at the end we just click train, we just execute train. So those are the three steps: downloading a dataset, then registering this dataset in Detectron2, and then training Detectron2. Those are the three steps, with the three more important steps in this notebook. So what I did is to take these functions, I copy pasted these functions, and I created my own scripts, which is doing exactly the same function. It's doing exactly the same. All I did was a copy paste. I took the functions and I pasted in this script, but I also did a few edits, so it's a little nicer, and it's a little more customized for training an object detector algorithm. If you look closer, you can see that this is fit for a semantic segmentation algorithm, the dataset registration. So it doesn't really fit the purpose of something that's strictly an object detection algorithm. I don't care about the masks. I don't care about the entire object. I only care about the bounding box. So this is, for example, one of the edits I did in this function, but it doesn't matter. All you have to take from here is that these functions, I have created these functions by copying and pasting the code in this notebook. It's basically a copy paste plus a few edits, but let's just assume it's a copy paste because it's a very small edit. So this is something I did before making this video, before recording this video, so you can see that everything is pretty much ready. And you can see that all for the train method, for example, this is where we are specifying all the config file, all the different configurations, all the different hyperparameters, and this function receives as parameters all the different hyperparameters of this function: the learning rate, the batch size, the number of iterations, how often we are saving a checkpoint with the weights we have trained so far for this model, and so on. So, and these are all default parameters. All these parameters they have a value by default. So when the user is calling this function, the only thing it has to specify is where is the data it's going to use to train, what are the class names, and the output directory, which is where the checkpoints are going to be saved. So if you look at this function from a high level overview, from a very, very high level, the user only needs to specify these 3 values, and that's it to train a model. So this is what I meant at the beginning when I said one of the things I want to show you with this video is how easy it is to train an object detector algorithm using Detectron2. How easy. For example, in this case, once I have cleaned everything from this notebook, once I have taken what I need, and once I have put together all this script, the only thing I have to do is to specify where it's my data directory and where it's my output directory and what are the classes that I'm going to use, and that's it. So this is the I'm going to make this available. I'm just going to put a link in the description of this video. And now let's continue, because the idea is to show you how to train an object detector algorithm. So in order to train an object detector algorithm, we not only need code, we not only need an algorithm, but we also need data. So I have created a directory for the data, but in order to show you how easy this is too, what I am going to do is just looking for the data and downloading a dataset live. So I am going to download a random dataset. So I'm going to search for dataset object detection YOLO format. We need our annotations to be in YOLO format. That's very important thing. That's a very important thing. So I have a lot of links. I'm going to open the first one. Let's see what we have here. It seems this is these are some instructions to create a dataset in YOLO format. So this is not what I need. I have already, when I was preparing this video, I noticed that this dataset, this link contains a traffic sign dataset, and it's already ready to be downloaded by clicking here. So the download is now completed, and you can see that this is the file we have just downloaded. This is the dataset we have downloaded. So this is to show you that we can do this with pretty much any dataset, and the only thing we need to do in order to train this custom object detector is just to put the dataset together and to do it like in the right format. If we create a dataset in the format we need, that's going to be enough to train our object detector. So I have just downloaded like a very random object detector. I looked for any dataset that's in YOLO format, and I have found this road sign dataset, traffic sign dataset. So this is the dataset I have downloaded, and if I look at this directory, this is our images and our annotations. So this is, for example, one of the images, and this is, for example, one of the annotations. These annotations are in YOLO format, so the first element is the class number, then it's the XYWH, which is XY width and height in the relative values. So this is going to be a float between 0 and 1. So this is basically the YOLO format. I'm sure if you are familiar with deep learning or machine learning, then you are familiar with the YOLO format. So what I'm going to do is to put this data in the structure we need. And if I go to this other file I have also created before making this tutorial, is the train-detectron.py, and I am going to show you in a few minutes everything I'm doing in this script. But if you take a look at the docstring to the comments at the beginning of this script, you can see that here we have some instructions about how to create our dataset, and it says that we have to specify our dataset in this structure. We need a data directory, then another directory which is train, and then 2 directories, one for images and one for annotations. And for every file we have in the images directory, we will need another file in the annotations directory with the same name, but a txt extension. So this is the structure we need for our data, and this algorithm is going to work for whatever data we put under this structure. That's the important thing. So I am going to my file system. So this is where I have specified this repository, this project. This is my data directory, so I am going to create a directory which is train. Then I am going to create a directory which is images, and another one which is ants. And according to this file structure, this is all I need in order to train my object detector. Then for my images directory, I am going to put absolutely everything, and then I can filter. Yeah, I'm going to just put everything, and then I'm going to remove the annotations. I'm going to take out the annotations. So that's it. Then I'm going to order by type. These are my images, and these are my annotations. So I have to go up until here. And I'm going to take this out to here. Okay, so I have created my two directories, images and ants, and in each one of these directories we have something that looks like this. In the images directories we have images, and in the annotation directory we have annotations, and for every file in the images directory we have another one in the annotations directory with the same name but a different extension. This is super important when you are training an object detection or pretty much any machine learning model. You always have to make sure that you have the same number of annotations that images. For example, in this case, we have 741 items in the images directory. We have 741 images, and we also have 741 annotations files, and that's perfect. That's how it's supposed to be. Because in some cases you are going to see errors or something if this is not if this doesn't match. If you have a different number in the annotations directory than in your images directory, it's something you need to fix with urgency. Otherwise you may have errors, or some things may happen when you are training your algorithm. So this is it for our data, and you notice how simple that was. I just did this with a random dataset I found by Googling or by DuckDuckGoing. So this is something super easy to do. If you already have a dataset in YOLO format, then you can do this pretty easily. And now I am going to walk you through this script through the train-detectron.py script. This is a script I did before making this tutorial, before recording this video, and you can see that pretty much all I'm doing in this script, I'm going to make things larger so you can see better, is to create this docstring where I'm specifying the user the format which needs to be provided in order to structure the data. I am remembering the user how the YOLO format looks like, which basically is for every annotation we have a line which is the class number, and this is the XY position of the center of our for bounding box, and then it's the width and the height of our bounding box. So if I show you, I already show you one of the annotations, but I'm going to show you another one. For example, here we have 3 different annotations, and each one of these annotations follow the same format: the class number, and then the XY coordinates of the center, and then the width and height of our bounding box, and this is in the relative values. This is a float between 0 and 1, as I mentioned before. So this is just to remember the user how to specify the annotations, what a YOLO format looks like, and then how the data needs to be structured. And then you can see that the only thing I am doing is just calling this arg parser and defining all these different input values: the root directory, the class list, the data directory, the output directory, and the device. And then the only thing I'm doing is to create another variable to each one of these arguments, I am not doing absolutely anything here. You can see this is just root dir. It's equal to args root dir. Class list file is equal to args class list. So I am just taking all the arguments from this input. And then the only thing I am doing next is calling this train function from my utils file. Then I am just calling this function from this file. And that's it. Once the user has specified what is this data directory and what's the output directory, and also what are the name of the different classes and where is this training is going to be done, if it's going to be done in a CPU or a GPU, that's it. That's all we need in order to train this custom detector. And I wasn't sure if I should do this code in the video so you can see it how I do it. I thought it doesn't have any value because it's just a few lines, and it's like, yeah, it's like defining these variables and then calling train. So it's super easy to do. It doesn't really add any value for you to look at me while I'm coding this. Another thing you should notice is that we are calling train and we are only specifying these values, and we are not specifying any of the hyperparameters. We are just leaving all the hyperparameters in the default values. This is basically because I have noticed that the Detectron is such a good algorithm. I mean, the way it's done, like internally, I have noticed that it's not really that sensitive to the hyperparameters we are using. These, for example, are some hyperparameters I use in most of the projects I work with. Every time I have to train an object detector, I just leave everything in these default values, and most of the times it's enough, and I can take the object detection algorithm I need from here. Obviously, if you're doing something that's a very sensitive application, you may need to do some tuning and to do some adjustments, because if you're doing something which is very customized and you need like a very perfect performance or something like that. But in most cases, I think it's like you can just leave these default values and it's most likely it's going to work. So this is it. And this is going to be enough in order to train this detector. Something I'm going to show you first before actually pressing play and training this algorithm is show you that one of the edits I did in this code is this the model weights. If I look at the notebook, if I look at this tutorial, we can see that the default model is this Coco instance segmentation mask RCNN and so on, and you can see that we are seeing this string here, and also here we are repeating the same thing twice. This is pretty much this is to specify the config file, to complete all this config file with a lot of information which is defined here, and this is to get the weights of this model. And what I did was changing this model by this one, which is for object detection. This model is for object segmentation, and I changed it for another model, which is object detection. And something else I'm going to show you before training our algorithm is to show you that you can choose from a variety of different models using Detectron2, and that's one of the huge advantages of using Detectron2. This is Detectron2 model SU, and if I scroll down, these are all the different models which are available in Detectron2, and these are all the different architectures you can use with Detectron2. If you are doing an object detection project, then these are all the different algorithms you can use in order to train your algorithm, in order to use in your project. If you're doing something which is more instance segmentation, then these are all the algorithms you have available, these are all the architectures, and you also have like different performance metrics for each one of these networks. So this is only to show you that if you want to specify another model, or if you're working in a different type of project, just take a look at these models too, and you can see different alternatives to use in your project. But now, going back to the script, going back to here, I have already shown you all the different files and everything we are going to use, and I think you already got an idea of how easy, how simple this is. Now what I am going to do next is to specify all these different variables. Something I haven't done, and it's important, is to specify this class list. It's not really that important. I mean, you can just create a dummy class list, and you can say each class name is going to be something random, like a random string, and it's not going to make a difference. You are going to train the same detector, but in order to make things nicer, I am going to use this file, which is the real class list. Every time we see a 0 in our annotations, it means the class is called prohibitory. And when we see a 1, it means danger, and when we see a 2, it's mandatory, and when we see a 3, it's other. So these are the class names for this project. It doesn't make a huge difference because this is only like a mapping from the class numbers to some strings, but let's just use these names so everything is the same as that dataset. And I'm just going to copy this in this directory, which is my root directory. I'm going to paste this file name here, and that's going to be enough. So if I go back to PyCharm, I see I need to refresh, most likely. Refresh, where is it, the refresh? I never use it. I know it's there, but I never use it, so I cannot find it. Reload from disk. Okay, so we should see we are not seeing it. Are we seeing it? And it's me the one who is not seeing it. Maybe if I restart, it's not really that important. I mean, the file is there, but I would like to see it in the file system. Reload all from disk. Okay, it doesn't matter. No, yeah, I'm not seeing it. So what I'm going to do is to leave PyCharm and get back. It's not that important, but I wanted to see the class name in my file system in PyCharm. So yeah, I'm restarting PyCharm, and now everything should be okay to continue. Okay, now I see class names. So this is the file we have just copied into our file system, and what I'm going to do next is to edit these variables. So root directory is going to be our current directory, so this is going to be this value. This is fine. Class list, this is a file we have just copied, and this is class names, classes names. Okay, then data directory, this is this root data directory, so in my case it's located in data. Output directory, this it doesn't really matter, you can specify whatever directory, and if it doesn't exist, then Detectron is going to create that directory before saving files there. So I'm just going to specify output. It doesn't really matter. Then device, in this machine I don't have a GPU, I only have a CPU, so I'm just going to use CPU. And that is it. Only by specifying those values we are going to be ready to train our detector. So now I'm going to press execute, and you can see it's loading a lot of things. This is the network, this is the architecture we are using, and what Detectron is going to do first before starts the training is going to register this dataset. So if you are using a very big dataset, if you're using a huge dataset with a lot of images, this is going to take some time. And then it's going to output something that it's related to the dataset it's using. In this case, it removed 0 images with no usable annotations, so that means it's perfect, and it's using 741 images. which is the exact number of images we have, it's always convenient for you to take a look at what happened when Detectron is registering the dataset, just in case something happened. And then it also shows you like a distribution of how all the different annotations look like. In this case, we have these four, and this is how many instances we have for each one of these annotations. You can see that we have way more instances of this class than the other ones, and this may be a problem later on, but it doesn't matter. This is just like a very dummy example to show you how this works. And when I say this could be a problem, I mean that we could be detecting this class more often than the other ones. It's always more convenient to have a more balanced dataset, but it doesn't matter. This is just like a dummy example. So this is pretty much it. What we will have to do now is wait until this is completed, until we have our weights from all the different iterations. But as I am using a CPU, this is going to take a lot if I do it locally. So I am going to stop this, and I am going to move all this process into an EC2 instance. But this is going to be all for this tutorial. This is how you can train an object detector algorithm using Detectron2 to train on a custom dataset. If you're curious to see the end of this training process, then I invite you to take a look at my next video where I show you how to train Detectron2 on an EC2 instance, and I am going to show you the entire process and also how to take the weights from this EC2 instance and how to evaluate all the performance of these different weights in order to see what's the best one for our project, what's the one with the best performance. I invite you to take a look at that other video if you are curious. And if you're not curious, then this is how you can train an object detector algorithm using Detectron2, and I am going to make this code available in the description of this video. If you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. My name is Felipe, I'm a computer vision developer, and in this channel I make tutorials about computer vision, machine learning, and I also talk about how to get a job in this field as a machine learning engineer or as a computer vision engineer. So if those are the things you are into, I invite you to subscribe to my channel. And this is going to be all for this video, and see you on the next video.